Good evening, and welcome to the inaugural lecture in the Leadership Lecture Series. This is a series of talks that we are hoping to bring you, where we are going to try and get some esteemed alumni from our ranks who happen to be leaders in their industries, in their work, thought leaders as well, and so they're not necessarily going to talk about the business that they're running, but rather some learnings that they have acquired during their professional careers, which we think will also be of great benefit to students in terms of helping guide their actions. Some of these talks will be more technically oriented, and I'm sure the faculty will benefit greatly as well. Today's talk by Dr. V. Sumantran, is on corporate cultures and innovation. Sumantran has had a very distinguished career, but I really think that the high point of his life came when he graduated from IIT Madras as part of the renowned 1981 batch, which is a vintage that has never been matched before or since, as all the experts claim. But since his BTech at IIT Madras, he has done MS and PhD in aerospace from Princeton University and Virginia Tech, respectively. And he also has a master's degree in management of technology from Rensselaer Polytechnic. He is currently Executive Vice Chairman of Hinduja Automotive UK, and he leads the group's expansion strategy, including sectors such as light commercial vehicles, construction equipment, IT, defense, aerospace, and technologies. He is a member of the board of Ashok Leyland Limited and Chairman Ashok Leyland Nissan Limited, Chairman Ashok Leyland John Deere Limited, and Chairman Ashok Leyland Defense Systems Limited. He is also Chairman of Defiance Technologies Limited, an IT and engineering consultancy, and is Chairman of Albonair, an emission technology company based in Germany. He serves on the Scientific Advisory Committee to the Cabinet of the Indian government. He also served on the Science Advisory Council of the Prime Minister of India. He is a member of the National Manufacturing Competitiveness Council. He is a member of the Global Technology Council of John Deere US. And he serves on the Group Advisory Council of the GMR Group, one of India's largest infrastructure enterprises. He is also a distinguished visiting professor at the Indian Institute of Technology, Madras. From 2001 till end of 2005, he was the chief executive of Tata Motors car business. During this period, he basically innovated the nano low-cost and area high-end car projects. He was a member of the board of Tata Cummins Limited, a joint powertrain company. He was also chairman of Concord Motors, an OEM-owned automotive dealer network. He served as president of the Automotive Research Association of India, chaired the Engineering Services Forum of NASSCOM. He also served as president of Society of Indian Automotive Manufacturers, and is chairman of the CII Chennai Aeropark Advisory Board. Before joining the Tatas, Dr. Sumantran had a 16-year career with General Motors in their R&D center in Detroit. So Sumantran is with us, and I invite him to come and give his lecture. I also request Professor Bhaskar Ramurthy to hand him a bouquet.
Good evening, ladies and gentlemen. It's great to be back in these wonderful grounds again. I have chosen to talk about a subject that I must start with a preface upon. These days there's a lot of talk of innovation. I think sometimes I think too much of it. In fact, these days when I tell my wife that, oh, by the way, I have to prepare for a talk, and she says, oh, please don't tell me it's one more of those innovation talks. So it does get jaded sometimes. But perhaps more to share with you, not so much this jargon about innovation, but really the experiences, the inspiration, And the kind of, this is perhaps more of a storytelling than it is any talk about innovation. And obviously this is based on personal observations. I do on other occasions when I'm on the lecture circuit have a talk that is more about generalized ideas about innovation. But frankly, to me, what is important is where it's been personal and where it has been possible to build upon something. So these are just, this is a bit of storytelling, and this is in a way almost chronologically what I've seen through in my working career. Next slide. You know, obviously I started my career as an aerospace engineer. I graduated with degrees in aerospace engineering. It just so happens that my other love was cars and motorcycles, so I ended up spending all my career in the other field. But this was an association very early in my working career that I really enjoyed. The person you see there featured is Paul MacCready. Paul MacCready is a real genius in the field of aerospace engineering. He was a professor at Caltech. He was, among other things, a world record holder for sailplanes, and most importantly, he's the person who designed the aircraft that you see here. This is the Gossamer Condor, the first human-powered aircraft to cross the English Channel. And what you see there in the gondola is a bicyclist who's pedaling, and it's this, that power that is transmitted to a propeller that is the sole motive force for this aircraft. And they were the ones who successfully flew across the English Channel with nothing but human power. The reason I start with this slide is obviously this is a great feat of innovation. That aircraft, for those of you who are from an aerospace background here, that aircraft that you see there has the wingspan of a 737 and weighs 32 kilograms. And I remember talking to Paul. By the way, Paul and I happened to work together on a different project. In fact, he and I own the world land speed record for the fastest wheelchair. And by the way, the speed record for the fastest wheelchair is 68 kilometers per hour. So during that project, we were talking to Paul, and I was, obviously as an aerospace engineer, I was marveling at this design, and I said, you know, what a fantastic design. It must have been truly a difficult challenge to overcome. Paul is a typical curmudgeon. He is a crusty old Californian. And he dismissed what I said by saying, no, we should have done better. It was actually over-designed. And I said, what do you mean it was over-designed? 32 kilograms, and you got the wingspan of a 737. And I said, how can you over-engineer this? And he said, no, we had designed the structure so that it would sustain at least 7 takeoffs and landings, because we knew it wouldn't fly on the first occasion. But finally, by the time we really flew across the English Channel, it was the 13th takeoff. So obviously, the aircraft was over-engineered. This, to me, was a phenomenal lesson. I mean, how many of you used the term factor of safety? Factor of safety is that huge domain of uncertainty where we brush things that we have an inability to either predict or control or manage to the degree that we would like to. Obviously, in an aircraft like this, a larger cushion, a larger factor of safety would have made the difference between a successful mission and an unsuccessful mission. And so this taught me, first, this pursuit of excellence to say, you know, we can't leave things mostly done, that we have to chip away at all the remaining elements. Now, the same concept you could think of, the Japanese have this concept called muda. Muda is waste. The whole concept of Japanese productivity is all related to elimination of muda, or waste on the factory floor. Wasted motion, wasted material, wasted effort is all muda. And I often wonder how designs that we have in the world today would bear themselves up to the kind of scrutiny that you would need for the concept of muda in design. What is muda in design, and what is waste in design? I think this was for me a very, very early learning. It was a learning about mindset. It was a learning about the art of possible. Indeed, the art of possible if we really challenge ourselves. Similarly, given the growing role of electronics in vehicles, we formed a joint venture with Continental. In the future, you will find that trucks like this, our G91 truck here, a U-truck, they will have onboard systems. In fact, this truck has this box on the right that you see. And this is a telematics box, so basically like an aircraft, it's communicating data back to the base. And it's not just GPS information about location. It's about speed, about the engine, it's about how the driver is using it, it's about the throttle position, about the braking, about the coolant temperature, about the oil temperature. A whole bunch of parameters are being constantly streamed back. So similar to those of you who are Formula One fans, when you see the race, you see the team engineers at the pit wall, and they're looking at banks of laptops with data coming. And so they know, in fact, yesterday's race, somebody relayed the news to Vettel to say, you got a problem with second gear, save second gear, short shift. Now this is because that data is coming telematics and streaming back to the data banks in the pits, and they're able to look at the temperature, they're able to look at the speeds, and they're able to relay information back. Well, this is not far from this, that you can actually today get data that is streaming back to the base for various vehicle parameters, and from that you can literally manage the fleet, manage the vehicle, manage the operations. And more importantly, when we first started to look at what we could get from the European supplier, again we found we couldn't afford it. But in our joint venture with Conti, this unit on the right has been developed with Indian engineers in our Indian joint venture. As you can see, the specs are even more comprehensive, and more importantly, it's at a far more attractive price. And finally, we felt that we needed to invest in the clean air technologies, that as we go to the future, we will have to reduce emissions from the tailpipe. So whether it is particulate matter, whether it is NOx, whether it is hydrocarbons. And you can see from Euro 0 to Euro 4, you can see the size of the rectangle going from the red zone to the blue zone, to the light blue zone, to the green zone, and to the dark green zone. This is the envelope that demonstrates the degree of reduction of exhaust emissions in modern vehicles. And to do this, we founded a company of our own, a 100% owned company in Germany, that makes the entire set of systems designed for NOx emissions. And here again, they've developed a very interesting SCR, Selective Catalytic Reduction System, which has an air-assisted injector of urea, and as a result achieves far greater conversion efficiency and at much lower cost compared to the typical European systems.
Let's, again, I want to thank Sumantran for coming and delivering this marvelous lecture. I would like to request one of our alumni, D. Chandrasekhar, Secretary of the Alumni Charitable Trust, to present a memento to Sumantran. The reason I'm asking DC to do it is because his enterprise, Tejas, actually designed this memento. So.